Hello, seventh graders. Here's an equation that we're very familiar with by now. You know how to solve this quite well. We follow the general principle that you can do the same thing to each side. Now, these are not sarcastic air quotes. These are, this is the approach. This is what allows us to solve algebra equations. An algebra equation is like a seesaw that's in balance, and if you add a quantity to the left side and you add the same quantity to the right side, the equation will still be in balance. And this equation is actually not in our seventh grade textbook, equations like this. In my view, that's a mistake for two reasons. Number one, it's not that hard to go from the ones that are in the textbook to this one. And the second reason that it should be in your textbook is because it's in all Algebra 1 textbooks. You need repeatedly to be able to solve equations like this when you're in an Algebra 1 course, and we're trying to get you ready for an Algebra 1 course. This is something you can master as a seventh grader. And of course, you have a couple of choices here. You could either add 5x to each side or subtract 3x from each side. I think I've told you before, I personally like to get the x's on one side first. You don't have to do that first, but I like to do that. Eventually, we want to come up with the number that we can put where each of these x's is to get a true statement. We want to get x equals a number. That's our goal. Plus 5x plus 5x. I think at this point, ladies and gentlemen, can I combine the two steps? You see how I've done the two steps together? That's not that difficult. On the left side, we get 8x, and then these add to 0. That's why I added 7 to each side. On the other side over here, these are going to add to 0, which is why I added 5x to each side. There's the equal sign, establishing the left and right sides that we keep balanced. This is 0, and then we have 4 there, negative 3 plus 7. So what's x? 1/2, right? Isn't that obvious? Divide each side by 8. 4/8 simplifies to 1/2. Let's go back up here. 3 times 1/2 minus 7 equals negative 5 times 1/2 minus 3. If we were in class right now, I would ask somebody, pick on somebody and say, what did I just do? And you all know what I did. I substituted the number 1/2 for the x in the original equation, and what are we hoping happens? We get a true statement. And 1/2 is the only number we can put where the x is, where each x is. And let me repeat, I've said this before, each of those x's has to be the same number. That's a fundamental understanding, agreement that we make in math. If this were an x and that were a y, well, you couldn't solve that equation, but an x and a y could be different numbers. But within the same problem, this x and this x have to be the same number. And in this case, I think it's 1/2. This here is 3/2. 3 times 1/2 is 3/2. Now it's 1.5, but watch what I'm going to do. I think I've suggested that you do this. Sometimes, rather than getting involved with mixed numbers, it's easier just to stick with the fractions. And 3/2 minus 14/2 is negative 11/2. 3 minus 14 is negative 11. So 3/2 minus 14/2 is negative 11/2. That's what our left side turned out to be. And on the right side, negative 5 times 1/2 is negative 5/2. Minus 3, but instead of minus 3, I'm going to write negative 6/2, minus 6/2. Negative 6/2 is the same as negative 3. Negative 5/2 minus 6/2 is negative 11/2. Look at that. Beautiful. Not only have we discovered that the x is 1/2, but we have proven that the x is 1/2. That is the number that we can put where each x is and get a true statement. You know this already. The point of this video is to show you that really you haven't seen the complete picture. There are two other things that can happen when you solve an algebra equation. We saw what usually happens, what we usually expect to happen when we approach an algebra equation like the last one. We solve for x, find the number that we can put where the x is to get a true statement. But there are two other things that can happen. You might think what I just wrote on the board is silly, and if you do, you're right. It is kind of silly, but let me ask this. What number can we put where each x is to make a true statement? Sometimes when students have equations like this or a little harder than this, we're going to see, I'm going to make it a little harder than this. Students will sometimes say, oh, x is 0, or x is 1, because they put 0 here and got a true, and 0 here and 0 here and got a true statement. So, oh, it must be 0. Well, you can put 1 there and get a true statement too. Put a 1 in for x and 1 in for x. Get a true statement. What numbers can you put in for x and get a true statement? Any number whatsoever, right? 2x minus 1 is always equal to 2x minus 1 no matter what the x is, right? Let's follow our training. Our training tells us to try to collect the x's on one side, right? So if we approach this very weird equation, if we approach it like we did the other one, we'd have to conclude, well, I must have to subtract 2x from each side to try to collect the x's on one side. But what happens? Well, this is 0, and this is 0, and the only thing that's left is this. And when you're solving an equation like this and you get to that result, you have to know how to interpret it. You have to recognize that as what kind of a statement. What kind of a statement is that? Well, it's true. That's a true statement. When all the letters go away and you get a true statement, what you conclude is that the x can be any real number. All real numbers are a solution. You could stay here until the end of time putting a number in here for x and the same number in here for that x, and you'll always get a true statement. That's pretty obvious, right? There's another name we can give, another way we can interpret this result. When the letters go away and we get a true statement, we can also say that what we were given to start with is an identity. An identity is something that's true for all numbers, which that statement is. So this is a second thing that can happen. Sometimes when you're solving an equation, you can reach the result that any number will work. All real numbers are the solution, or the equation that you were given is an identity. But you're probably not going to encounter equations that are that obvious, that simple. So let me give you a more realistic situation. Solve this equation. Pre-algebra students, Algebra 1 students. You know, the equations with the x's on both sides are not in our textbook. Well, so obviously these aren't either, because these have equations, have x's on both sides. If you have x's only on one side, then you're going to get a single at the start. If at the start of the equation you have x's only on one side of the equation, you're going to get a single number solution. Now, one of the things that I think I've already suggested to you is when you get an algebra equation that you need to solve, wouldn't it be nice if it were simpler? Of course it would. So simplify the left side and simplify the right side if you can, one or the other or both, before you start trying to do things to both sides. It's much easier if you simplify each side first. Okay? When I say each side, left equals right. Okay? Now, This left side here is exactly the same as 2x minus 1, right? 5x minus 3x minus 1 can be simplified. You can combine those two terms, and 5x minus 3x is 2x, and then you have the minus 1. Look at the other side. The distributive property, right? Apply the distributive property, multiply x by 2 and get 2x. 2 times negative 5 is negative 10. And then we still have that plus 9 there. So we can do one more thing to simplify. The left side is 2x minus 1, and the right side, we can combine those two numbers, add those two numbers together, and get, look at that. I did that on purpose. I started out with, 2x minus 1 equals 2x minus 1, and hopefully you see it's obvious that any value of x will work there. 2x minus 1 is always equal to 2x minus 1. Well, this thing here, 5x minus 3x minus 1, is 2x minus 1 in disguise. I disguised it. And then I disguised 2x minus 1 over here in a different way using the distributive property. But it's still 2x minus 1. We already know that all real numbers will work here, or that it's an identity. These are two ways to show that you know what's going on, because when you subtract 2x from each side here, you get the true statement, negative 1 equals negative 1. You have to interpret that result to realize that any number whatsoever for x will work. All real numbers. The original statement was an identity, meaning it's true for all values of x. You could stay here until the end of time, putting the same number in for x here, here, and here, and the left side will always be equal to the right side. Now it's time for us to look at the third and final thing that can happen when we solve an algebra equation. The first thing is that we can get a single number that the x equals to make a true statement. One solution. In this second situation, any number whatsoever will work. All real numbers will work. And there's a third situation. So let me ask you this, students. The directions are here: solve for x. Try to find the number you can put where the x is to get a true statement. That's our mission. Well, we're going to fail. We're going to fail in our quest to find a number we can put where each x is to get a true statement. Now, we're not going to fail the test because we're going to know how to interpret the results. We're going to recognize that we cannot find such an x. Now think about this for a minute. This is not much more difficult than the first one, but it's totally different. This x and this x have to be the same number, so therefore 2x and 2x are the same number, right? 2x is some number. X is a number, 2x, 2 times that number, it's a number. So over here on the left, we're subtracting 1 from that number. And over here, we're adding 3 to the same number. Can that left side ever be the same as that right side? The answer is no. Never. We could stay here until the end of time putting numbers in here for x, the same number here and here. We will never get the left side equal to the right side. In fact, let me ask you this question. This is not too hard. Not only is the left side never equal to the right side, but we can go further. There will always be the same relationship between the left side and the right side. The right side is always going to be greater than the left side, no matter what x is, no matter what 2x is. The right side over here will always be greater than the left side. They will never be equal. Here's the question, which is not that hard. By how much? By how much is the right side greater than the left side? Always. Isn't it 4? Right? Let's say x equals 6. So we would get 12 minus 1 or 11. And over here we would get 12 plus 3, or 15. 11 is less than 15. In fact, it's 4 less, right? This 15 is 4 greater than the 11 because the 3, the plus 3, positive 3, is 4 greater than the negative 1. See, let's look at it like this. There is 2x. No, it doesn't matter what x is, but 2x is a point on the number line, okay? In this case, the 2x was 12, right? Because as I said, let x equal 6, the 2x would be 12, right? Well, where is 2x plus 3? 1, 2, 3. There's 2x plus 3. Where's 2x minus 1? Right there. 2x minus 1. And that difference, that distance between those 2 points, 2x plus 3 and 2x minus 1, is 4 units. And the 2x plus 3 is 4 units to the right of the 2x minus 1, always. Okay. They're never the same. What if we apply our strategy? What if we follow our training? That's what I like to say sometimes. Follow the training that you've been given. And we would try to collect the x's on one side. Similar to before, right? Subtract 2x from each side. We think our goal is to get x equals a number. That's actually not going to happen here. But in order to try to get that x by itself, subtract 2x from each side. Get rid of the x's over there. But the problem is, well, not really a problem. The situation is the x's are going to go away entirely from both sides, leaving us with negative 1 equals positive 3. Now, what can you say about that statement? In a previous equation that we solved, we got a true statement. Remember, we got negative 1 equals negative 1? We said that was a true statement. This is a false statement. All the x's go away, and you get a false statement. So you conclude there is no solution. We're not going to have x equals a number. No solution. You could stay here until the end of time, putting an x here and the same x here. You will never get the left side equal to the right side, and that's pretty obvious. Can you guess what I'm going to do now? Well, I'm going to put funny glasses and a fake beard and a hat on these two things, the left and the right side. I'm going to disguise them. You'll see. Wow, look at this monster. Solve that equation. Take your time. Don't be overwhelmed. Don't look at something in math, word problems. Right around this time, we're also working on some word problems, integer problems, and rectangle perimeter problems this week. And I think I told you in one or more of those videos, don't be intimidated by, any one of us, if we just read some of those word problems and just sort of try to take it all in at once, it's overwhelming. It seems overwhelming. Step by step, little by little. With this equation, there's a left side and a right side. The reason that I called this a monster and why it might seem overwhelming is because there's a lot of stuff there. But you can simplify. Left equals right. And before you try to do something to both sides, do the same thing to both sides, which is our theoretical approach that we take. Our training tells us to do the same thing to each side. But before we do that, we should try to simplify. Simplify the left side, simplify the right side, one or the other, or both. In this case, you can simplify both of them. Now, as you look at that left side, it should look familiar to you. I've given you quiz questions that look just like that, where you have to simplify. There are 4 terms, 2 x terms and 2 number terms. You can add the 2 x terms and you can add the 2 number terms to take the 4 terms down to 2. That's why it's called simplifying. 2 terms is easier to deal with than 4 terms. Please understand the reason we can do this is because all of those terms are on the same side of the equal sign, right? We're not doing this. This is something I sometimes see. Plus 5x plus 5x. Some people are treating this as if there's a minus sign here, but no. We're not doing that. We're simply adding negative 5x and 7x, and that gives us 2x. And then we're adding 3 and negative 4, which gives us negative 1. Does that look familiar? I did this on purpose, ladies and gentlemen. That left side is 2x minus 1, just like in the previous example. Okay? It's just in disguise. How about the right side? Well, once again, on the right side, I put the distributive property. This time it's negative 2 times the parentheses. Negative 2 times x is negative 2x. And now, this is not 2, it's negative 2, and that number there is not 3, it's negative 3. So we now have a negative times a negative. Negative 2 times negative 3 is positive 6. And then we still have the plus 4x and the minus 3. Now, after applying the distributive property, just now on that right side, now we have something very similar to what was over here on the left. We have 4 terms that can be simplified down to 2. By combining the x terms, we add the x terms together, and we add the number terms together. Over here we got 2x minus 1, and look at that right side. Does that look familiar? You seeing it? Negative 2x plus 4x is 2x, and 6 minus 3 is positive 3. This is the exact same equation that I just gave you. 2x minus 1 equals 2x plus 3, except in disguise. So the conclusion is going to be the same thing. We're going to subtract 2x from each side, try to get the x's on each side. All the x's are going to go away. We're left with negative 1 equals 3, which is false. Therefore, we conclude that there is no solution. 2x minus 1 is equivalent to the original left side, and 2x plus 3 is equivalent to the original right side. I hope I've convinced you that there's no x that you can put here and here to get a true statement. 2x minus 1 will never be equal to 2x plus 3. But this original thing is exactly the same mathematical quantity as 2x minus 1. They are equivalent because we did legitimate adding here. And this original thing that we did here, applying the distributive property, adding the like terms, this 2x plus 3 is exactly equivalent to that mess up there. So now you see the complete picture. Sometimes when we're solving an algebra equation, we get x equals a number. The number that we can put where the x is or where each x is to get a true statement. That kind of usually happens. These other two examples, in practical terms, as we go through our lives as math students in middle school and high school and beyond, most of the time it's that first case where we're going to get that solution for x. But you have to be aware that the other two possibilities are there. The x's could all go away and you get a true statement. And when that happens, you conclude that any number will work. All the real numbers will work. Or in other words, the original equation is an identity. An identity is something that's true for all numbers. Or all the x's can go away and you get a false statement. And when that happens, you must conclude that there's no solution. No value of x you can put, no number you can put where each x is to get a true statement. Just won't happen. So now you have the complete picture. I hope this has been enlightening, and you should always want to expand your math horizons. Take care, 7th graders. It's been a pleasure. Bye-bye.